This video is about the discriminant and using the discriminant to find the number of real solutions and how to simplify complex expressions. Let's get started. First, let's remember the quadratic formula, which is that x is equal to the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the part inside the square root, this part in here, is actually pretty important. So important that it's been given the name of the discriminant. So the discriminant is b squared minus 4ac. And it's called the discriminant because it discriminates, or it tells you how many real solutions there are in the quadratic equation. So over here on the left, I have three quadratic equations. And I can put these into Desmos or a graphing calculator and graph them. And I'll put a sketch up here of what those graphs look like. Okay, so we can find the number of real solutions by the number of times it intersects the x-axis. Okay, so this is the solutions as if it was 0 equals that equation. The number of real solutions would be the number of times it crosses the x-axis. In this case, there'd be 2 real solutions. So let's look what the discriminant is for this equation. Okay, keep in mind that the number in front of x squared is a, and the number in front of x is b, and this constant term is c. So if I plug into b squared minus 4ac, then b squared is a negative 1. So it is a negative 1 squared minus 4 times a, and a is also 1, and c is negative 2. So plugging that in, negative 1 squared is positive 1. Let's see here, minus 4 times 1 is 4. 4 times negative 2 is negative 8. So subtracting a negative 8 gives you 1 plus 9, 1 plus 8 equals 9. Okay, let's look at the second one. And again, the number of solutions is if 0 is equal to this quadratic equation. Okay, and so I can look at the number of times it crosses the x-axis, which looks like exactly 1 time. So what does that discriminant look like? Well, let's see. And the discriminant is 0. And finally, this last one, if I was solving the equation 0 is equal to 2x squared minus 3x plus 6, how many solutions are there? This never crosses the x-axis, and so there are 0 solutions. So what does that discriminant look like? Well, let's see. And we get a discriminant of negative 39. So the question is, how can the discriminant of a quadratic equation, this is only true for quadratic equations, help you determine the number and type of solutions? Well, if it is positive, then we have 2 real solutions. Okay, if it is 0, then we have 1 real solution. And I'm going to point out this has with multiplicity of 2. Okay, if you have 1 real solution, if the discriminant is 0, it'll actually it'll bounce off of the x-axis. You'll have 1 real solution, and that solution has a multiplicity of 2. Now, if it is negative, then you have 0 real solutions, and you have 2 complex solutions. And that's because you'll get the square root of a negative number, which gives you I and complex answers. Let's remember that complex numbers are the results of square roots of negative numbers. Okay, now let's look at powers of I as we're kind of gearing up to solving or simplifying expressions of complex numbers. So remember that I is the square root of -1. Okay, so what would I squared be? Well, it'd be the square root of -1 squared, and a square root and a squared will kind of balance each other out, cancel each other out, and we get -1. Okay, now I cubed, if we ever get that far, the best way to think about this is it's really I squared times I, right? And I squared is -1, and so we get negative I. So I cubed is negative I. And I to the fourth, the best way to think about that one is to think of it as I squared times I squared, which is -1 times -1, which is +1. One more thing to point out, because it's right here, is if you had some other power of I, like let's say I to the 11th power or something, okay, you could pull off multiples of 4 because those are always equal to 1, okay? So you could look at I to the 11th is I to the 4th times I to the 4th times I to the 3rd. Okay, and I to the 4th we know is 1, I to the 4th is 1, and I to the 3rd we know is negative I, and so what we get here is negative I. So I to the 11th is negative I. And you can pull off multiples of 4 and simplify this down. So if you ever see that, that's how you would do it with higher powers of I. So let's look at one example where we will look at a quadratic equation, look at the discriminant, figure out how many real solutions, and then solve it and see if that agrees with the number of solutions we think we would get and the kind of solutions we think we would get from this quadratic equation. Okay, the discriminant again is that b squared minus 4ac from the quadratic formula. And so this discriminant is -39. So I know that that means that I'll have 0 real solutions and 2 complex solutions. So let's go ahead and solve this. I get x equals, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So plugging all those numbers in, I get negative, well, what's this here? So it's negative b, and b is -1. So be careful about that negative sign. Plus or minus the square root of b squared minus 4ac. But because I did the discriminant, I've already done this. So I'm just going to pull this number right here and put it in there because I've already done that work. All over 2 times a, and a is 2. So I get a -1 is a +1 plus or minus the square root of 39 all over 4. Let's see here. Does 39 have any perfect square divisors? 4 doesn't go into it. 9 doesn't go into it. 16 doesn't go into it. There are no perfect squares that will divide 39. Whoops, I missed my I. Let's pull, I guess, a reminder that this negative sign will get pulled out of the square root and it be an I, and it's not in the square root, it's out of the square root. Okay, and I can't simplify root 39, and so I'll write this as 2 answers. X equals 1 plus, actually it's 1/4, right? So I have 1/4 and I have this fraction, so it's 1/4 plus root 39 I over 4, and x is equal to 1/4 minus root 39 I over 4. So I'm not surprised that I found 2 complex solutions because the discriminant was negative, and that negative gave me a negative inside the square root, which gave me complex solutions. One last idea for this video is that we will add and subtract to combine like I terms. Okay, Remember that when you multiply I times I, you get I squared, and that I squared is -1. Okay, that's the most important power of I to be aware of because it comes up the most frequently. Okay, now as you add, subtract, multiply, and divide complex numbers, okay, you treat I as if it's any other variable like x. But if you get other powers of I, like I squared, then you simplify that down and you combine it to give an answer in the form a plus bi. So here's an example on the left. Okay, I will distribute this -7, and I get -14 minus 7i. Okay, and then I have a minus I. And then I'll distribute this. I just treat it just like a variable. 5 times 1 is plus 5. 5 times 5i is 25i. -2i times 1 is -2i. And then here we go. -2i times 5i is -10i squared. Okay? Nothing is new here. I is just like any other variable like x. The only difference is we say, oh, I know that I squared is -1. So let me rewrite this, changing I squared into -1. Okay? And now I can combine like terms. So let me combine the whole numbers together. So I want it in the whole numbers first. So whole number, and this will also be a whole number. So -14 plus 5 is -9. Let's see here, -10 times -1 is a positive 10. So if I have -14 plus 5 is -9, plus 10 is 1. Okay, and the complex terms, I have -7i, and minus I is -8i, plus 25i is 17i, minus 2i is plus 15i. So the way to simplify complex expressions is to treat like any other variable. But if you get higher powers of I, like I squared or I cubed, you simplify those down to be -1 or like -I, and then you simplify it down into an a plus bi format where it's the whole number plus or minus a whole number times I. And that's how you do it. All right, this video is about the discriminant and using it to find the number of real solutions and how to simplify complex expressions. Thanks for watching.